This is the second video lecture on chapter 12, which is about class hierarchies and interfaces. And this part, we're going to be talking about superclasses and a very important object-oriented term called polymorphism. And let's just start with superclasses. And right now what you're looking at are the slides from the Litvin textbook. And I'm not presenting them because I think it's useful to see the notes that they've provided here as well as we go through these slides together. So every object in Java is ultimately an extension of the object class. And as it says here, object is a concrete class, which means that there are all of the methods inside the object class are fully defined. If we want to, if we have a more specific object, like a balloon, for example, we can overwrite some of these methods in our particular classes, and we do that sometimes. We've done that with the toString method, and then also it's common to do that with the equals method, because if two balloons are equal, that might look a lot different than generally if two objects are equal. So just a couple important pieces of information from this slide. The one that the object class is the sort of base class of all the objects that we write in Java, even if we don't say extends object, and also that object is a concrete class. So we've done a little bit of this too already, but know that if we had a class called birthday balloon, and I'm just going to scroll back to the class hierarchy here and notice the birthday balloon is actually a subclass of the round balloon, and the round balloon is a subclass of balloon, and by default balloon is a subclass of object. So we're down here looking at the birthday balloon class now, and what we see inside of the constructor is that rather than writing a whole bunch of code here that does something with this information that's passed to the constructor, we just call the superconstructor. We call the constructor of the superclass, and we pass the necessary parameters to that class. And that is a very important way that we use this class hierarchy to organize our code. And then notice there's something specific about a birthday balloon. It actually has an integer age number that we're going to store here in this class rather than passing that to the superclass where all this other information is stored. So and again, this is just a piece of the class hierarchy that we're looking at here. So you can use the superclasses constructors inside the actual constructor of your object. And there's a couple of interesting things here to notice. That first of all, that you have to call the superclasses constructor one way or another, but we might not do it explicitly. Instead, if we don't call the superclasses constructor explicitly, like which is done right here, then by default the noargs constructor is called in the superclass. And check this out. If that constructor is not defined, it will cause a syntax error when you compile. Just to remind you about constructors, if your class, if the birthday, if the round balloon class didn't have any constructors at all written into it, then there would be the default constructor, which would take no arguments, that Java automatically provides. But if you actually have defined even one constructor in the round balloon class, then there is no default no args constructor anymore, and you would have to actually define that if it was to be called. So the message here is that we get kind of a puzzling error from when we run into this case. But let's just take a look at the next slide here and see what happens in our birthday balloon case. So when you create a birthday balloon by using the word new and calling its constructor, it does some stuff, and then it calls the super constructor of the round balloon, which calls the constructor of the balloon object, which calls the constructor of the object. And so all of those constructors are going to be called all the way through the class hierarchy. So that's kind of interesting. Once you have a, after we're done constructing an object like a birthday balloon, and our constructors are all taken care of, then we can access the methods in the superclass using that word again, super. And so here's an example of when you might want to do that. If you want to draw a birthday balloon, basically what you're going to do is you're going to draw a round balloon, and then what they're doing is they're changing the color, and in order to write the age at a particular location on the balloon. So again, drawing a birthday balloon is really just drawing a round balloon, and that's what's happening right here. And then we do a couple other things. We change the color to black so that the letters show up, and then we can actually draw or write the text in this case on the balloon. So this is an important way that we extend objects functionality as well, and we use this keyword super not just to call a superclass's constructor, but also to access particular methods within that superclass, which is what's happening here. So, and this is just an example from the swing library, and it's just demonstrating that if how the super dot call is used within that library as well. If you want to paint a canvas, for example, then you're going to call the super class, in this case, which is JPanel, we're going to call that paint component method. So that's pretty much it. We've used the word super before, so this is not a new idea to us. It's just reinforcing how we use the superclasses, constructors, and methods in the subclass. And then just two more slides to go here. This is a pretty complex word by itself, and also a pretty challenging concept to wrap our minds around. And how Java achieves this is a subject that's mentioned down here in the notes, but that's not tremendously important to us. We just want to understand really what is meant by polymorphism. And I think the next slide helps us understand it a little bit better. If notice that if you want to paint all the balloons that you have in this balloon array, and this is what's happening in the balloons of all kinds application that we were looking at last time. If you want to paint all of these balloons, they might be some square balloons and some round balloons and all these different types of balloons. But in this code, we don't know what types of balloons are stored in this array, but we know that they should all have a draw method. And so we just call the draw method for each balloon in the balloon array. And what Java does automatically, and I'll go back and say that, like once we have defined a common superclass, and balloon in this case, then polymorphism just happens for us. So what Java does is it knows to first figure out what type of balloon you're actually dealing with and execute the actual draw method within that particular balloon. So if B is a square balloon, it's going to call the draw method in that square balloon, and so on. So this is what polymorphism gives us is we can generalize our code by having just a collection of balloons, but when we want to operate on those balloons, um, then we're actually implicitly calling the draw method within that specific type of balloon. And that's what polymorphism does for us. It allows us, it has Java handling all these different types of balloons in a really intuitive and a way that is consistent, so that the correct method is called every time. There's one more lesson coming up on this stuff, and it talks about interfaces, but that's all for right now.